Good morning, good afternoon. Hope you're having a great Wednesday. We made it to the middle of the week. Today we're starting Big Ideas Lesson 8.3. As you see on the calendar, this is actually a 2-day lesson, so it will take us today and tomorrow. I'm just looking at the calendar and realized that I wished you happy Monday on Tuesday, and I wished you happy Wednesday today, but it's really Thursday because there was no school on Monday. So that makes it even better. It's Friday Eve. All right, so we are in Big Ideas 8.3. And again, when you go to OneNote, you will have to tap on the icon, choose Printout, and that will give you the big background. All right, so we're doing 8.3 in 2 days. We're going to do about half of it today and half of it tomorrow. So we're only dealing with our learning target and first two examples today. And it does build right on what we did in 8.1 and 8.2. You notice the standard form of a quadratic. Yes, I'm going to write it every time. It is very important for you to memorize. Y equals ax squared plus bx plus c. So on Monday, we dealt with the changes that A makes. It stretches and shrinks, might flip it upside down. Yesterday, we dealt with what C does. It moves the graph up and down. And today, we're going to add in the last piece of standard form, the BX term. All right, learning target. Graph and describe functions in the form f of x equals ax squared plus bx plus c. And as you know, but I'll say it every time, f of x is the same as y. So what will you be able to do in order to know you've met your learning target? You will be able to find the axis of symmetry and the vertex of a quadratic function. You'll be able to graph quadratic functions when they have ax squared, bx, and c. And you'll be able to determine a maximum or minimum value. All right. Let us scroll down to key idea. Graphing f of x equals ax squared plus bx plus c. We know that the graph opens up when a is positive, and we know that the graph opens down when a is negative. The y-intercept is always whatever c is, and it's always all. Sorry, no, that was vertex I was thinking of. The y-intercept is c. The x-coordinate of the vertex. Okay, so here's where we have something very, very new. Knowing that the y-intercept is c is new, but also knowing the x-coordinate of the vertex. We can find that by doing negative b over 2a. Negative b divided by 2a. And because that gives you the x-coordinate of the vertex, that's also how we find the axis of symmetry. All right, so we see here in this graph, the axis of symmetry is x equals negative b over 2a. The y-intercept is always at 0, comma, c. Our vertex we use for the x value of the vertex, it's negative b over 2a. And then you plug y into the equation to get the other to get the y value or the y coordinate of the vertex. So let's do some practice with that. These instructions are asking us to find the axis of symmetry and to find the vertex. And we're going to do that with the equation f of x equals 2x squared plus 8x minus 1. I'm going to write this off to the side. I think I'll change my background to graph paper just in case I need to do some graphing. I'm going to take the smaller one. Okay, so we have f of x equals 2x squared plus 8x minus 1. In order to find the vertex, in order to find the axis of symmetry, which is also the x value of the vertex, we do negative b over 2a. All right, so here's a. A equals 2. Here is b. B equals 8. And here is c. C equals negative 1. Okay, maybe you even want to label that off to the side. A equals 2, B equals 8, C equals negative 1. All right, so we're going to take negative B over 2 times A. So negative B is 8 divided by 2 times A, which is 2. So this is negative 8 divided by 4, which equals negative 2. So our axis of symmetry is x equals negative 2. Now to find the rest of the vertex, remember this negative 2 is the x part of our vertex. To find the rest of it, we are going to plug negative 2 into the equation and see what y is, right? Or f of x, because they're the same. So we take our equation, f of x, or y, is equal to 2 times negative 2 squared plus 8 times negative 2 minus 1. So you can put all that in your calculator if you want. I'm going to use order of operations. 2 times 4 plus 8 times negative 2 minus 1. 8 minus 16 minus 1. Negative 8 minus 1. Negative 9. So that means our vertex is the x value from our axis of symmetry, negative 2, and the y value we found by plugging it back into the equation, negative 9. Is that all it asked us for? Axis of symmetry and vertex. Now, if we were going to be graphing this somehow, for our vertex to be at negative 2, negative 9, let's see, we're going to need to have some negative x and a lot of negative y. Negative 2, negative 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's our vertex. Our axis of symmetry goes right through here also. We know that A is positive, so this is going to open up somehow. We know that the y-intercept is negative 1. That means it's right here. Ooh, this is going to be skinny. Because this is symmetrical, and we'll look at this again in a second, we know there's a dot the same distance away on the other side of the axis of symmetry. And then we try to make this as smooth a curve as we can. It should have touched that point without being pointy at the bottom. All right. I would like you to try this with number 1 and number 2. Just find the axis of symmetry and find the vertex. Pause the video, find those things, and then come back to check your work. Okay, welcome back to the video. We're going to use, I should make this y equals 3x squared minus, I think, 2x. Yes. So in order to find the axis of symmetry, we are going to do x equals negative b over 2a. So a is 3, b is negative 2. We don't have a c, so that would be 0. So the negative of negative 2 is positive 2 over 2 times a, which is 3. That's 2 over 6, which is 1/3. So the axis of symmetry, x equals 1/3. Now we put 1/3 back into our equation. Y equals 3 times 1/3 squared minus 2 times 1/3. 3 times 1/9 minus 2 times 1/3. 3 times 1/9 is 3/9 or 1/3. 2 times 1/3 is negative 2/3. So y equals negative 1/3. That means our vertex is 1/3, negative 1/3. Axis of symmetry, x equals 1/3. Vertex, 1/3, negative 1/3. For number 2, x squared plus 6x plus 5. X squared plus 6x plus 5. We do x equals negative b over 2a, negative 6 over 2 times a. There's no number in front of our x squared. That means it's 1. Negative 6 divided by 2, negative 3. Now we take that negative 3, we plug it back into our equation. Negative 3 squared plus 6 times negative 3 plus 5. 9 plus, nope, minus. 9 minus 18 plus 5. 9 minus 18 is negative 9 plus 5, negative 4. So our vertex is negative 3, negative 4. All right, finding the vertex and the axis of symmetry. Now, going into example 2, now they're asking us to find the domain and the range. So this is going to be kind of what I showed you on the graph I made real quickly for the example, I think it was right before example 1. When we want to find a graph and then the domain and range, we want to find the axis of symmetry, find the vertex, use C, which is our y-intercept, and that will help us graph 2 more points. So, what do we have here? F of x equals 3x squared minus 6x plus 5. F of x, or y, equals 3x squared minus 6x plus 5. All right, first, axis of symmetry. X equals negative b over 2a. The negative of negative 6 is positive 6. 2 times a is 3. That's 6 divided by 6, which is 1. Now we take 1 and put it back into our equation to find y for our vertex. 3 times 1 squared minus 6 times 1 plus 5, 3 minus 6 plus 5, negative 3 plus 5, and y equals 2. So our vertex is 1, 2. And we're going to go ahead and graph that. So I think I'm going to move this over here. Vertex is 1, 2. Let's create a coordinate grid. That's why it's so great that we have this graph paper background. Label your axes. We're going to put our axis of symmetry at x equals 1. We're going to put our vertex at 1, 2. And we know from our equation that our y-intercept equals 5. 1, 2, 3, 4, 5. So we have our axis of symmetry, which we know cuts our parabola right in half. So if I have a y-intercept here and it's 1 point, 1 unit away from the axis of symmetry, then I'm going to have another point 1 unit away from the axis of symmetry on the other side. And this is going to be my parabola. We try to make it as smooth as possible with no point at the bottom. And in order to find the domain and the range, we know that the domain, all real numbers, it can be any x value at all. And the range has to do with our vertex. It's y is either greater than or equal to or less than or equal to that vertex point. So that's right here at 2, and everything is above that. So y is greater than or equal to 2. So given an equation, we found the axis of symmetry, we found the vertex. We graphed the y-intercept and then graphed another point on the other side of the axis of symmetry. And that allows us to find our domain and our range. Let's try this for, I'm going to let you pick. You choose either 5 or 6 or 7, and I'll show you the answers for all of them. So pause your video, find the answer for either 5 or 6 or 7, and then come on back. All right, I'm going to do these in different colors so that you can clearly see which one I'm working on. First over here, I'm going to find the vertex and the axis of symmetry. So for 5, I'm going to use orange. X equals negative 4 over 2 times 2, which is negative 4 over 4, which is 1. Now I plug 1 back in. 2 times 1 squared plus 4 times 1 plus 1. That's 2 plus 4. Ooh, I made a mistake there. Back it up. It's not 1. It's negative 1. Negative 4 divided by 4 is negative 1. All right, let's try again. 2 times negative 1 squared plus 4 times 1 plus 1. 2 times 1 is 2. 4 times negative 1 is negative 4 plus 1. That's negative 2 plus 1. So y equals negative 1. That means our vertex is negative 1, negative 1. When I come over to graph it, I'll graph it in orange. So we have an axis of symmetry at negative 1 and a vertex at negative 1, negative 1. There's our vertex. C is 1, so our y-intercept is at 1. And then we're going to go same point on the opposite side of the line of symmetry. We can graph our parabola, and we see that domain, all real numbers, range, y is greater than or equal to negative 1. All right, number 6. Our axis of symmetry is the negative of negative 8, that's positive 8, over 2 times a, which is 1. So 8 divided by 2 equals 4. Now we take that 4 and plug it back into the equation. We get 4 squared is 16, minus 8 times 4 is 32, plus 7, which is negative 16, plus 7, which is negative 9. So that means our vertex is 4, negative 9. We probably don't even have to graph this one, because we know that our range always has to do with the y value of our vertex. And we know that because a is positive, this graph opens up. That means our range is going to be greater than. So our domain would be all real numbers, and our range would be y is greater than or equal to negative 9. For number 7, axis of symmetry, the negative of negative 10 is positive 10 over 2 times negative 5. 10 divided by negative 10 equals negative 1. Now we plug negative 1 back in. Negative 5 times negative 1 squared minus 10 times negative 1 minus 2. Negative 5 plus 10 minus 2. 5 minus 2, or 3. So our vertex is negative 1, 3. We know that we have a domain of all real numbers and a range. This one opens down, so that means our range is going to be y is less than or equal to 3. That is our entire lesson for today. This is going to be something that takes a little bit of practice. Okay, what is the most important thing to remember? I'm going to go back up to the very beginning where our learning target is. Standard form, y equals ax squared plus bx plus c. We have to remember to find the axis of symmetry. We are going to do x equals negative b over 2a. In order to find the vertex, plug y into the equation. No, plug x into the equation to find y. It's also important for us to remember that c is the y-intercept. Domain is always all real numbers. And range is always y is less than or equal to or greater than or equal to the y value of the vertex. Okay, so those are the important parts to remember for today. And your assignment is on Google Classroom. Happy Thursday, now that I have figured out the correct day of the week.